very much for attending my session today. As you see in the presentation, that we are going to talk about preventing the security apps, something that maybe some of you are still considering about how to implement the security. For me, security is something nonsense. There's no secure apps in the Android. All the things are able to be compromised, but the thing that we do is only slowing down the potential risk, the something the inevitable. I think the slowing down is perfect terms right now for the Android because as long as you are protecting your app, then intruder or attackers are able to figure out the way to manipulate your app. And unless you are having a lot of resources, like a lot of budget to acquire the licensed product like, as you know, Dexguard or AppDome, but some of companies doesn't have many resources. So today we will explore about some of the best practice that already used by my company in terms of delivering the secure apps for the customers. Let me introduce myself. My name is Sidi Permana. I'm coming from Indonesia, Jakarta. I don't think I can stand here and share the experience with you because very surprised that Google approved my travel supports, which is very over budget. And then some of the people in the Southeast Asian and then Indonesia are very jealous and envy to me because luckily Sidik is able to be in Sydney. And I'm a Google developer expert since 2015 and founder and CIO of the NBS.dev. I have my company, software engineering company in Jakarta. Right now we are still growing and we manage like 80 employees there. Then quite big. And I am actively being a community contributor since 2013. That's why 2 years later, Google select me as the Google developer expert. So for everyone doesn't know about the GDE, GDE is the very special programs for the very selective developers recognized by Google, and to be GDE, there's a certain of the interviews and then approval from the GDE community itself and then Googlers. So about my company, we are working with some of the enterprises, startups and local governments. We're serving many, mostly Indonesian companies and Indonesian startups that in multi-sector and multi-industry. So disclaimer, I'm not a security expert and apologies for my English. And then I'm just a software engineer, yes, although my daily activity is managing the business, but coding is my passion and the curiosity to deliver something secure and proper for our customer is something that I can do right now to assist my engineering team. So maybe some of us think that security is always left behind and security is less priority. Even though if we do development, security is not becoming main priority. Because we always pursuing catching up the features development. Features and features. As long as it delivered and then makes everyone happy, then it's done. So the security may be only put in the very less priority, even in the end of the development before the penetration testing can be done. So we always put the security is not a habit. This is like in the beginning of our company, we don't know how to implement the secure codings itself. So we have a lack of understanding. We always focus on the features. So the security is only becoming the tech debts for us. And then we don't have any working standard at the time. So even though we are not understand about the platform itself, then we don't know about how to use it properly. Because if we talk Android, if we don't understand about how to use Android platform properly, this becoming one of the security concern at the end. Another thing is about we don't know what to do. We don't know how to do, and we don't know how to test. So to ensure about what to do to ensure our application is secure, we don't know about what the reference that to be followed, and what security checklist that needs to be to follow, and for the how we do, we don't know how we are able to harden our application, how we are able to protect our sensitive data, and then how to test. We don't know how to make how we think like penetration tester or the security intruders can do to our application. So for the vulnerability risk itself, we define into two. First one is the business logic, and second one is engineering implementation. Business logic mostly is coming, the vulnerabilities for coming from the business logic is the failure of the defining of the analysis of the features that we want to develop in detail. So it allows the people to do abusive access to our features in application. For instance, the referral features. This is one of our experience. We ever designed the referral features for one of the ride hailing in Indonesia. And at the time, we don't think about the detail about the possibility of the abusive access of the referral features. Then at the end, it making a business loss for our customers. And then we learn after that. So the first learn is we need to think about the detail end-to-end very carefully about the flow that we design, the data that we define, and the process that we handle. Another thing is the engineering implementation. This is coming from how we understand about the platform itself, how we do the secure codings, how we are able to make at least the communication between the remote and the client server, remote and the client are able to run as expected. The main point of the engineering implementation is about improper platform usage. Like if we talk in Android, so mostly we are always forget about how to persist data securely. Some of us may be using shared reference, but shared reference, if we able to see in the debugger, we can get the very plain data there in the XML. But if we implement the encrypted shared reference, the data will be encrypted, as well as like when we do with the room database, we can utilize with the SQL shipper to encrypt the database. So nothing 100% secure as we do, we can explore, but the thing that we do is trying to make at least since the beginning, the application are able to deliver the functionality while maintaining the security. So this is a common sources of the threats of the Android recently. First one is malware or malicious apps. Malware and malicious apps are coming from the understanding about the limitation of the Android platform itself. Second one is the Android fragmentation. It's not easy to handle all the things in Android. You know that we have many variants of the OS. Some of the OS, the latest of the OS, like more than 10, Android 10 to Android 13 are more secure, but 10 below are not secure. Even though Google is always enforcing about the Android security updates, but it's very easy to ensure that Android itself is secure. Another thing is about the device of the Android, many devices that we handle. The third one is the lack of the platform understanding. So doing Android development is one thing, but understand about how to use the component of the Android properly is another thing. For the application download outside from the Google Play, it's hard for the users to ensure to ensure the users that only download our application from Google Play, because when they are downloading same application from different sources, it potentially the application is fake or it is malware that to be downloaded. Customized OS, rooted device. Rooted device is the one of the key points of the key problems of the Android security is the rooted device. Whenever the device is rooted, so you allow the potential security threats coming to your device. 7, the vulnerability from libraries and third-party APIs. So whenever you are using the third-party libraries coming from GitHub or Maven or Gradle, please ensure and double check and doing the scan for the third-party libraries. Maybe your code is very secure, but when you are depending to the other libraries and you don't do the scanning of the libraries, the potential threat coming from this potential threat maybe can coming from those libraries. Number 8 is the remote source communication over the internet. So we ensure that all the communication using the HTTPS, TLS, but if you don't use it, don't implement like SSL pinning correctly, or proper authentication, so the connectivity between remote source communication, from the client to the server can be compromised. So for the vulnerabilities, this is now 11 things that common in Android world. First one is application cloning. So you can Google it, APK cloner, APK cloner. APK cloner is making your application to be cloned. So there's two application in the one device. Intent injection. Intent injection is the capability of the malware to redirecting or activating the component of the other apps. Data hijacking, the capability of the malware application to hijack your data, especially from the external storage, which is not encrypted. Reverse engineering, your application is decompiled. Application tampering, after application, your application is decompiled, and then intruder or penetrating intruder are able to add some of the malicious code. Unauthorized access to remote sources, yes, if they are able to decompile or understanding your code and understanding about how communicate between a client and server, and then it can harm our entire platform. SSL pinning attack, as long as we are able to do with the SSL pinning, but potential to do with the attack, SSL pinning attack can still happen. Dynamic remote instrumentation, those like Expose, those like Frida, able to do with dynamic remote controlling our app. Web view hacking, this is common thing that when we are using the web view and somebody with the good capability able to hack with the JavaScript using our web view. Anyone ever heard about strain hook? Strain hook 1 and 2. Strain hook is the task hijacking. If you know that in Android, we have like task affinity. Strain hook 1 is about the task affinity. So every task in Android has its parent. And then task hijacking is making the other application can be launched as our application using manipulation of the launch mode and task affinity. Another one is APK patching. It is very complex. The APK patching is not required to decompile. The signature is same. They only repackage our application with malicious code. So patch our application. For instance, maybe like when there's application using license API, and then the APK patching is able to remove that license API without any code. So for the sample of the APK patching is the Lucky Patcher. You can download it. So where to start? Here how we do at NBS. First one is we follow to core app quality and security best practice. We do with developer.android.com provide the privacy and security for the basic minimum implementation of the security in Android. Follow that documents, and at least you will have like very basic minimum of the security implementation. Second one is the security tips. It is more detailed about how you able to use platform correctly. Like for instance, why we need to have like additional parameter called exported and set the value of the non-public activity to the true to the false, or we are protecting our content provider to signature level, or we are able to how to use web view correctly. All the things will be detailed in the security tips. Second one is the OWASP, Open Web Application Security Project. Top 10 is coming from 2016. They're still drafting about the top 10 mobile security issues in the 2023. But we take the issue from the 2016, and it's still relevant. Let's explore it. First one is the improper platform usage. Improper platform usage mostly about lack of understanding and misuse of platform features or failure to use platform security controls. If we compare to the previous vulnerabilities or threats, it will be intent injection, data hijacking, web view hacking, or strain hope. So what we do, first one is we set param exported false to your app component in manifest, so it will limit access from other apps to access our component. So this is the reason why we set the component like activity, which is not publicly to be accessed from other application to be false. Similar way like we do for the services, broadcast receiver, or even content provider. Second one is if you use the broadcast receiver among the only in your app, considering using local broadcast receiver instead. Third one is when you are using the custom permission, then please ensure that you are setting the protection level into signature based permission. Be mindful when you are using web view. The one is please validate all the incoming URLs to be loaded in your web view before you are doing the follow-up action. Use launch mode for single instance for the application who exposed to other application to be accessed through implicit intent. When using intents, please avoid the nested intents, and then when you are using pending intents, just set up a flag immutable and then flag one shoot to avoid the replay attacks from the intruders. Then don't send the sensitive data over IPC. And then the last one is the set always allow backup to false. So it will be limit for the other application can take our backup. So this is the example, the basic that we always used to do. The permission, we set the signature for the custom permission. And then for the application itself, we set up to false for our backup. And then for the component like activities that unable to be accessible from other application, we set the exported to false. Number two is the insecure data storage. It is about how we are persisting data in our application, whether we are storing data in the key value, file, or even in the SQLite. So what we do is every sensitive data must be stored in the key store mechanism. So key store is equal to the keychain in iOS. So if you have like user tokens, so the good way is the storing data into key store. Another thing is when you are implementing key value data to be stored, considering using encrypted shape reference. So the data will be encrypted whenever it is opened by other application. Another thing is implement the SQL cheaper when you are using the room database. Implement file encryption and use internal app storage first for the application storage instead of the external storage. No data, no sensitive data stored in the external storage, and then when you are planning to store the data into external storage, please using the scope storage access framework. This is a simple sample the way I do for the encrypted self reference. First one, we define the master key. I use the IS-256 GCM mode, and then we define about some parameters here, and then the rest is process. The rest process are similar way like we do with the self reference. So what about the SQL cheaper? It's very easy. You just get the instance of the support factory, and then after that you adding open helper factory for the into the database builder of the room. So when the other parties are download your SQL data, when it open, it cannot be done because it cannot be open because it requires like a password to be open the data, to see the data. In secure communication, ensuring all communication to remote sources are using secure connection through SSL and TLS. Don't use the HTTP. Use the SSL and HTTPS. So potential threat will be unauthorized access to remote sources and SSL pinning attacks. Enforce to use HTTPS whenever you are using HTTP. Even though you are using the WebSocket, please ensure that it is under the SSL. So another thing is the implement proper the network security configuration, and then if you are using SSL pinning, please consider about updating the SSL pinning on the fly. In our case, we are making it automatically update using Ultra. This is open source project. Can make the SSL updates for the certificate on the fly without we are uploading new application every year. Enforce to encrypt all sensitive data inputs, including phone number, email, password, and etc. whenever they are transmitting into your remote server. This is the way, like if you are using the OKHTTP, this is the way, one of the way that we can do with the certificate pinning in the OKHTTP. So insecure authentication. So this one is very interesting because some of us are using the GWT, some of us using the auth too, but do we implement correctly? Yeah, because if we are able to scoop the access, we are able to scoop the request, it can make harder for the intruder or irresponsible party to access our resources, because if they are able to authenticate to our app easily, and they can manipulate our backend easily too. So limit the lifetime of the user tokens is very it's a thing that can be done easily, and invalidating all the sessions that frequently. Implement using reverse token if you are using the OKHTTP. Implement the throttle authentication to limit the excessive attempts. Implement risk-based authentication. And if needed, you are able to use the biometric for the certain of the use cases. So this is the way what we do in the session authenticator, because the user token in the 5 minutes, I think the material is still long. Okay, okay, I can speed up. Okay, cryptography. Okay, this means that using the cryptography to store your sensitive information. Please use only the Google recommendation for the Android. Yeah, use the secure randoms for generating your seed, and then this is the way for the quite secure when you are using the ISGCM without padding for the transformation. Insecure authorization, yeah, we do for the authorize the users or the device to access our application. So what we do is, again, using OAuth and JWT correctly, check if the application is able to run our root devices or not, or the application is able to only running on real device or in emulator. It depends on the business. And if the application are very location sensitive, check if the mock location application are enabled, are installed. If you are familiar with the Google Play app integrity, it will be checking your application whether this application is legit and downloaded from the Google Play. And detect the source installation from Google Play or not, and then detect if there's application cloner installed. My latest experience is we have a big giant database that containing mock application list, cloner application list. So there's a specific from our clients that requesting that the security is a priority in the project. Google Play app integrity is allow you to check whether your application is legit or not. If the users are using the application downloaded from other apps or side loads, potentially they are unable to access your resources. Number 7, client quality code, simple implement secure coding, doing static analysis or dynamic analysis. What we can do, we can use the OWASP, but keep in mind that some of the open source library may be suspected as the high severity security, and we can take it all, targeting the minimum for the latest version for the Android SDK, and when using the third-party libraries, please do properly scan for the library and make it keep update. Like what we do in company is we integrate our DevSecOps into the Sona Cloud and Guardrail. So Guardrail will be helping you for doing the dynamic analysis, especially for the code for the libraries that you are using. So other tools that can help you using the static analysis and dynamic analysis is the MobSF. It is very simple. It is used by the researcher only, some of the developers and researcher of the security. And very simple. You are only using the Docker, and then you upload the APK, and after that, the result is coming for you for free. So the thing is, only you are inspecting which part that able to be fixed. But sometimes the result is resulting the false positive, and you need to discuss about it to to your team and your clients. Code tampering is when the source code, the application, or the request is the tamper from the person in the middle attacks or from the intruder. So what we do is obfuscation using ProGuard. Although the ProGuard is not good enough because it is open source, free, compared to another thing like DashGuard that able to do with more proper. And implement app integrity checking by Google Play App Integrity. Reverse engineering, we cannot avoid for application to be decompiled. And what we do is obfuscation again, remove logs from including third party used by our app, and then protect access to third party services using the signature. For example, map key on the Google console, and then again, check the Google Play App Integrity, because Google Play App Integrity has many capabilities to check whether the application is a fake application, the compiled application, modified application, or a tampered application. So this is very simple to remove logs from all the application component, including the libraries installed in your application. Okay, here. Yeah, external functionality is maybe your application is good, secure enough, but your library may be producing the potential issue from your app. So don't print any your HTTP request in logs when producing the release app. This because whenever I connect my device into the Android Studio, I still saw the many applications are printing the logs as well as they are logging the HTTP request. So another thing is the properly scanning your third-party library. Do manual code review if needed. Beware and be mindful when you are sharing your non-production APK to others. So just ensure that you are sharing the APK to people you trust, the organization you trust. If you have any form input, please define kind of the data input and perform strictly validation. If you are receiving the URI from other application, please do the validation for that URI, incoming URI. And case by case, if you are developing the application that performing like inputting the security key, like PIN, so maybe you are able to develop your own keyboards to avoid the keylogger. So number 3 is we follow the mobile security testing guide, the full compact, all the things there, and from the basic understanding about how to test testing the security from the mobile into how you are able to do it with some of the tools that are provided by the communities. So number 4 is connecting the development into your CI/CD pipeline, security into the CI/CD pipeline. So we do with the CIF-Life approach applied, enforces a strong culture for the policy and security is priority, enforce the secure coding, and automatic security testing practice to CI/CD pipeline. So things like guardrail, things like MobFF, things like Sonar Cloud is able to be connected to your CI/CD. Depends on how you configure your CI/CD. So what we do right now, we are standardized. We develop our internal tooling. So in Android itself, we have developed our internal tooling and library. So it's injected into our code base and our skeleton. So whenever the developer starting new project, the security is already accessed. So they are able to use many times when they are starting new projects. Case by case, it depends on the project that we have. If we are handling the project from the health industry, and then probably we are need to follow the compliance, as well as when we are dealing with the financial application or banking apps that we need to follow about the regulations that to protecting data or do secure application on that industry. So the recap is we know how to do. What to do is we understand about the product itself, we understand about the functionality, we uh, doing the evaluation and carefully analyzes our features. Our experience in making the referral features to be like becoming a fraud is something that we learn very hard, and it's becoming the business loss. Then since then we very carefully thinking about end to end the business process, business logic, and see the threat model that we can cover since the beginning. How we do the DAC and OWASP are able to deliver you the good information. Just learn it, and then if you have more resources, considering to use tools like DexGuard and AppDom. This is not promotional. This is based on our experience. The last one, we are helping the banking application, and then the banking application itself, we implement the DexGuard. So tools like Expose, tools like Frida is not able to manipulate our application. And how to test? Mobile application security testing guide, you just follow that, and then connecting all the things with your DevSecOps. Always update to target SDK to the latest one. Hardening or slowing down is something like core concept. Security is something inevitable. APK is able to be compromised, able to be decompiled very easy. And just follow the guidance on the DAC, OWASP, and MTSG. The important one is understanding about the platform itself, the platform component before you are using. And then to protect the users and customers is our responsibility as engineer. And keep being observant, because learning about security and is not only doing the coding, it's very fun, because we know about how the penetration tester and then intruder are able to do manipulation of our application, even modify our application. That's all. Thank you.
Any questions, guys?
Really nice presentation. Thank you.
Thank you.
My question is that MobSF is free to use?
Yes, MobSF is the open source.
Is there any concerns if I put like is it privacy and so on, you know, like if I put
No.
the product in there?
No, because this is installed on your machine.
Sorry?
This is installed in your machine using Docker.
Oh, in local Docker?
In local Docker.
Okay,
In local
cool.
Docker.
So there's no privacy leakage and stuff?
No. The thing is, like what I said earlier, the result of the MobSF potentially producing the false positive. So you just figure out and communicate to the relevant parties about to handle it.
Thank you.